Students, today we are going to see about Aston Mass Spectrograph. Francis William Aston in 1990 built his mass spectrograph with electric and magnetic fields in different regions along the path of the particles, which result in a focused beam. So these particles are nothing but the positive ray particles. So this is the Aston Mass Spectrograph. The principal or the main aim is to determine the atomic mass of the isotopes of an element. So determine the atomic mass of isotopes. So you can see the diagram of Aston Mass Spectrograph here. These are the two slits through which your positive rays are allowed to move, and they pass three pass through these two plates, that is P1 and P2. So they are deflected by electric field, and after that they are deflected and deviated by the magnetic field. First time they are deflected and deviated by electric field, and after that they are deflected and deviated through the magnetic field, and finally they are focused on this photographic plate. So you can see the principle here. The same diagram is again repeated in this notes. Consider positive ions having the same value of E by M. So we are going to consider positive ions which is having the same value of E by M. E is the electronic charge and M is the mass, but travel with different velocity. So these ions are having the same value of E by M, but they travel with different velocities. So when they pass through an electric field, as already we have said, they are passing through electric field as well as through the magnetic field. So when they pass through the electric field, they are deviated and dispersed. So those dispersed beam passes through a magnetic field which is perpendicular to the electric field. So again they are dispersed and deviated because of the magnetic field. That magnetic field is perpendicular to the electric field. So finally they are brought to focus to a photographic plate kept at suitable distance, right? So now coming to the theory of the Aston Mass spectrograph. So you know the principle. We are saying that the positive rays are having the same E by M value but travel with different velocities. They are passed through electric and magnetic field. This electric and magnetic field are perpendicular to each other. So when they pass through the electric field, they are deviated and dispersed. And those deviated and dispersed positive rays, again when they pass through the magnetic field, they are dispersed and deviated. Then they are focused on the photographic plate which is kept at a particular distance. Now coming to the theory of focusing, right? Action of electric field. So this is the action of electric field. You can say that x1 be the linear displacement of the particle on leaving the field in the direction of electric field. So the displacement is nothing but x1. So you are going to find that x1. We can say that the positive ions having the same value of E by M but traveling different velocities. Already we have said that pass through two slits S1 and S2 when they enter the electric field between the plates P1 and P2. That length is nothing but L1. So X be the electric field intensity acting over the length L1. So X is the electric field intensity. Then V is the velocity of the particle. Then that deviated angle is nothing but d theta, right? So x1 be the linear displacement of the particle. So x1 is equal to half into xe divided by m L1 by v the whole square. So this we are getting it from s is equal to ut plus half at square. So u is a 0, therefore the first term is 0. Half a is nothing but xe divided by m, right? Xe divided by m, then t square is nothing but L by V. L is nothing but that linear displacement. Then V is the velocity. So distance by velocity gives you time. Therefore, it is L1 divided by V the whole square, which is substituted for T square. Theta is the angular displacement. Then you can write L1 into theta, right? Distance into that displacement can be written as x1. X1 is the linear displacement. As we know, x1 is the linear displacement and L is the length. L1 is the length. So that linear displacement can be written as distance into your angular displacement. That is L1 into theta, right? So you can calculate theta from here. So x1 divided by L1, already know the value of x1. X1 is nothing but the linear displacement. Then L1. So if we write L1 in the denominator, then L1 square, L1 into L1, that one L1 will get cancelled. Therefore, theta into V square is equal to X E L1 divided by M is equal to constant, right? Then differentiating it, d theta into V square. Okay, it's clear? So you're differentiating this equation. So yeah, left hand side you are having theta as well as V square. So you're keeping V square as constant and differentiating d theta. Then you're differentiating V square, keeping theta as constant. So you're getting this, which is equal to 0, right? So I can divide by V square theta. V square theta, if we divide it, we shall get d theta by theta. V square get cancels. Then here also 2 dv divided by v is equal to 0. From this you can get d theta divided by theta is equal to minus 2v dv divided by v. So this is the angle of dispersion due to variation of velocity of ion particle produced by the electric field. So due to the way already we have said that we are having the same E by m value but different velocity. Therefore, this variation of velocity of ion particle is creating angular dispersion, that is d theta, right? Then action of magnetic field after passing through the electric field, these things, that is the positive rays are passing through the magnetic field, right? So what is that length in magnetic field of length L2, which is perpendicular to the electric field. S2 be the linear displacement, as already we have seen that S1 is the linear displacement for electric field and S2 is the linear displacement for magnetic field, and phi is the angular displacement. So in electric field we are saying that theta is the angular displacement. Here phi is the angular displacement. So now we can find S2. So for S2 also we are writing the same equation, that is S is equal to ut plus half a t square. Half a t square is nothing but this. So after simplification we are getting this value, right? So again for phi we have to divide S2 divided by L2. So here also we get one L2 gets cancels. Therefore denominators L2 will get cancels, numerator alone L2 will be there. So then again phi v is equal to 1 by 2 b e l square divided by m is a constant, right? So again you are differentiating with respect to phi. So d phi, so you can write this, dividing by phi v, d phi divided by phi plus dv divided by v is equal to 0. From this you can get that d phi divided by phi is equal to minus dv by v, right? So from equation 1 and 2, we can say that in both ways we are getting that when we compare these two things, right? Minus 2v dv divided by v is equal to here minus dv by v, right? So uh, from 1 and 2 we can get that d theta by dt is equal to d theta by dt is equal to 2 into d phi by phi. Okay, here we are only having extra 2, isn't it? So 2 d5 divided by 5. So this relation we are getting from these two equations. So if we remove 2, we'll be having only dv minus dv divided by b. So both the right hand sides are equal. So you are putting this 2 here. So when we cross multiply this, we'll get 2 d5 by 5. So action of electric and magnetic fields. So action of electric and magnetic fields. The strength of the direction of magnetic field be so arranged that the dispersion produced in unless the dispersion produced by the electric field, thereby bringing the beam to focus at the photographic plate F. So we can say that AB is equal to small a. Thus AB is equal to small a, and we can say that BF is equal to small b. This is due to the magnetic field, and here it is due to the electric field. So the linear displacement produced is nothing but the distance of a plus b. A plus b into, you have to write that angular dispersion, that is d theta. So the angular dispersion by the magnetic field is, again magnetic field is b into d phi. Okay, here it is total, we are saying that a plus b into d theta, alone by the magnetic field is b into d phi. So we are equating these two things, that is a plus b into d theta is equal to b d phi. So when we simplify this, bringing a b terms together on left hand side and phi and d theta on another side, we are getting this equation. Already we know that d phi by d theta can be written by phi by 2 theta. From equation 3, you know this value. Okay, then a by b is equal to 2 theta divided by phi minus 2 theta. Okay, so this is the equation for straight line passing through A and making an angle 2 theta with the direction which the beam takes after it leaves the electric field, after electric field. So the photographic plate has to be kept on this line. If A is equal to B, 2 theta is equal to phi minus 2 theta, then phi is equal to 4 theta. So from this you can get the value of phi, right? So the focus is obtained at a reasonable distance from N. So from N, photographic plate should be placed at some reasonable distance from N. Here we are saying that. So this for this distance only we are calculating this, right? So description of the apparatus, you know that here is the discharge tube where the positive rays are produced and they are passing through these two slits, and you are getting an electric field when they pass through these two plates, that is P1 and P2. After that they get dispersed and deviated, then again they are, when passing through this magnet, they are again deviated and they fall on this photographic plate. This is the description of the apparatus. So how we are going to detect the isotopes? To determine the mass of the isotopes of an element, the element is mixed with the other element whose atomic masses are to be masses are already known. So you know one unknown isotope, mass of isotope which is to be, whose mass is to be found. So that element should be mixed with the known atomic mass of the element. So the positive rays produced in the discharge tube, the traces of all the elements are fall on the photographic plate. The distance of traces of known masses are measured from the given reference point on the plate. So the calibration graph is drawn connecting the distance with the atomic masses. By measuring the distance of the traces of isotopes of the element from the reference point, the atomic masses are obtained on the calibration graph. So for having that reference point, we can measure the isotopes of atomic masses of the isotopes of an unknown element. So Aston's identified 212 of the 287 naturally acquiring isotopes and became the first Nobel laureate in chemistry in the area of mass spectrometry. Okay, so he found about 212 isotopes masses. So limitations, the mass scale is not linear, that one. Then traces on the photographic plates are not straight, but they are curved. These are some of the limitations. Thank you, students.